Square root 2 is not a rational number. So that means that it cannot be written as a ratio of two natural numbers. And this is a classic proof. And it's a classic example of a proof by contradiction. So this is how it goes. Well, we actually assume the opposite. So let's assume that square root 2 is actually in the set of rational numbers. So what does that mean? That means that square root 2 can be written as a divided by b, where a and b are, natural numbers. Well, let's say non-zero natural numbers. Just the usual ratio, usual fraction you've seen. So that's the initial assumption. And we also assume that a and b have no common factors. Okay, well, it's like, so for example, it's like 2 divided by 4. Well, that's those two numbers, they have a common factor, namely 2, and it can be simplified down. So there is a reduced form, a unique reduced form for the fraction. So this is what we mean. Okay, so it is in this form. This is not a problem because whatever a and b you have, you can always turn it into a reduced form. So, well, then we just choose those a and b. So a and b have no common factors. So let's start working out the consequences here. If square root 2 equals a divided by b, then I can square both sides. So I have 2 equals a squared divided by b squared. And from that, I can easily say that, well, 2 times b squared equals a squared. I just multiplied by b squared. So let's look at this one. What this says, we can conclude that, well, a squared is even, so it's divisible by 2. It has a factor of 2, and from that we can also conclude that a is even. That's a basic property of numbers. So if a is even, then I can actually write a as 2 times d, which is d is just a suitable number for that. So a equals 2 times d. And now what I do is that I look at this one, 2 times b squared equals, and now instead of a I write 2 times d. That's just to make sure that this is actually squared. So that will be 4 times d squared. Okay, and it's 2 times here, 4 times there. I can simplify by 2. So I have b squared equals 2 times d squared. Oh, we've seen something like this before. And well, this just says that, let's just shortcut that using the same logic, as b is even. Okay, and now let's just put this one together. A is even and b is even. So what we can conclude that a, b are both even. So then they have a common factor, namely namely they have 2. Okay, so what's the problem here? Well, you know, we said that A, B have no common factors, and just we went through logically, and now we have A, B, they have a common factor 2. So there is a contradiction here. We have a statement which happens to, it looks like it's true and false at the same time. That's not good. So logic cannot take that. Well, so what happened here? There is a mistake somewhere. So where is the mistake? And you can check that in each step. Did I make any mistake? And it turns out that it's like, okay, it's fine here, it's fine, it's the same. No mistake there, it's no mistake there. The only possibility is that our initial assumption that square root 2 is actually a rational number and can be written as a ratio of 2 whole numbers, that's the only place where it can go wrong. So we conclude that, yeah, we proved that square root 2 is not a rational number.